Hello, everybody. Thank you for joining today's episode of What's New in Data. I'm super excited about our guests. We have some awesome topics today. We have Barzan Mozafari, CEO of Keebo.AI. Barzan, how are you doing today?
Doing pretty well. Thanks so much for having me.
Yeah, absolutely. Barzan, you're an expert in this field. There's so much incredible stuff going on in terms of the implementations with Snowflake, Databricks, data lakes in general, and it's growing to such a massive scale. And we're going to talk about that today. But first, I wanted you to tell the listeners a bit about yourself.
Sure. Happy to. I'm a co-founder of Keebo.AI. Prior to that, I was an academic. I was a professor in computer science at the University of Michigan, Ann Arbor. Before that, I was at MIT and UC Berkeley and UCLA. Before that, I also worked for a number of companies in this space. I pretty much spent the last 2 decades of my career doing research at the intersection of AI/machine learning and database systems.
Excellent. Yeah, so you bring an awesome technical research background, and now it's applied in this incredible product that you're building, which really solves some critical problems for data teams that are operating at scale in sort of the intersection of data engineering and FinOps. But I wanted to first talk about this at a high level. So your product Keebo.AI does focus on cost optimization. What are the biggest inefficiencies you see generally in how companies use Snowflake today? And do you see any common mistakes that lead to runaway compute costs?
I think there's a lot of interesting sources of inefficiency. So like we basically, our product, so just for the viewers, what Keebo.AI does is that we're a data learning platform. We actually, our models learn from how your own users and applications interact with your own data in the cloud, where, whether it's Snowflake or Databricks, and then use that to automate and accelerate the tedious aspects of the interactions between the data teams and the cloud data warehouse. And then that allows them to actually get more out of the platform. So some companies use that to reduce their spend on their Snowflake bill, on their Databricks bill, etc. Some of them use it to actually enhance their productivity, to get more done with the money that they're spending on these powerful platforms. And sometimes people use that to actually improve performance, for example, to get more done with a smaller team, right? Improve queries and whatnot. So with that bit of context, to answer your question of what are some of the common patterns we're seeing, I think it's just, I wouldn't call it necessarily mistakes that teams make, but it's more about how these platforms have created new patterns in how some of the traditional data engineering and data pipelines are no longer as effective, right? So to sort of look at the bigger picture, there's a reason why the likes of Snowflake and Databricks have been very successful in this market, right? Like what they've done traditionally, uh, if people had to rely on these centralized on-prem data warehouses, go to DBAs, go to a centralized data team, and everything basically had to go to that bottleneck. But what the likes of Snowflake and others in this space have done is they've really lowered the adoption barrier, right? Now, it's significantly easier for organizations of any sizes, like, a startup of like 2 people, all the way to companies of like, 50,000 employees can leverage data. Any team can just tap into data, and that time to insight is drastically gone down. That's all great, right? That's the positive side of the story. But the side effect of this is that the flip side of this is that now you got more users tapping into more data and doing more things with it. And because it's so easy, they're also, bringing in more data, they, combining more data sources. So when you have a situation where more data is being queried, more data sources are being combined and joined together, and then you have more users querying that, that means your modern data pipelines are significantly more complex, right? And it's not just about the mistakes that people make. It's just that there's a human limit to how much you can optimize a very complex pipeline. And like now add to this complexity, the fact that now that you have a lot more users querying this data, then it's just a natural fact of life that not every user is a database expert, right? Back in the
Uh-huh.
day, you had a BI analyst who knew exactly where to find what kind of data, how to hand tune and hand optimize every single query. Now you have an analyst from the supply chain department. There's someone from the marketing team. There's someone from sales ops. Like they're all writing queries, and to put it in light terms, not everyone who's writing SQL queries has taken has a degree in computer science, right? So some of those SQL queries have some room for improvement, right? Let's just be honest about this. But now you've got like millions of these queries hitting your Snowflake.
Yeah,
It's
yeah,
just
that
it's just a matter of skill, right?
absolutely, yeah, and I like the way you put it, but you're right. It's to use a marketing buzzword, Snowflake and these data platforms have democratized data
Exactly.
uh,
I
very
think we're
well.
the side effect of democracy.
and uh and sure, like they made it easy for large companies to sort of build this customer data platform that everyone can use across different levels of expertise. So yeah, you might have people who are non-technical just doing like a select stars and dumping it into a Excel file and filtering there. And and there's really it is really great because it's increasing the efficiency and how fast companies can make decisions with data, and what types of teams can make decisions with data. Because like you were saying, traditionally, yeah, you would have a very trained BI analyst who's working with a very finite set of resources in an on-premise data center, right? And they have to write really great, efficient queries, and everything has to be planned because that capacity was built out by an IT engineer who says, this is running on a 48 core box, right? And in our janitor closet. In our data center, but now everything's in the cloud and it's just like a utility, anyone can use it. So but that's great that you're solving this problem. And your product interestingly leverages AI to automate some of this query performance tuning. Can you walk us through how AI is being used under the hood?
Yeah, absolutely. So, if you think about the complexity of what's happening, right? The way these days people talk about AI is sometimes misleading, right? Like I sometimes joke that like you see people who are basically selling cookies pitching AI, right? It's like you don't need AI for everything, right? There's situations where you don't need AI or an AI is not applicable, right? So if you look at the complexity of the data pipelines, the fact that you've got millions of these queries hitting your cloud data warehouse at different times by different teams and trying to glean different types of insights from your data, some of these queries are pretty complex, right? So that's where I say it's humanly impossible to make the optimal decisions. It's humanly impossible to make sure that every single query is hitting a perfect optimal warehouse. It's humanly impossible to make sure that every single warehouse has the optimal settings of resources. Like, and it's not just a matter of effort because right now, let's say at today, for example, at 9 a.m., a medium Snowflake warehouse was optimal for my reporting workload. But 2.5 hours later, a medium is not enough. I need to go to a large. Maybe after 5 p.m., I can go down to an X small. Maybe a sudden report comes in. I need to boost it up, right? I need to bump up the size. So making these changes continuously by analyzing millions of statistics and calculations, it's where actually, but that's the sweet spot for AI. I call sometimes what we do at Keebo, we're building an infinitely patient, infinitely competent DBA. And like a lot of people have seen what AI can do when they go to ChatGPT and ask a very complex question. They want ChatGPT to research something and distill it down. We're leveraging AI in a very similar way when it comes to optimizing your cloud data warehouse, right? So we actually analyze millions of statistics over the last whichever number of days of this warehouse, which queries have run on it, which users have sent what kind of requests, what has been the performance, how long each of those queries spent in queuing. And based on those, we make optimal decisions about, okay, right now, this is the optimal size for this warehouse. Right now, to get the SLAs that the users care about, here's the kind of resources we need. Right now, it's idle. Right now, this is unnecessary. We can get away with a smaller, let's say, compute size. Let's say right now we decide that, hey, we need more clusters, we need smaller clusters, larger clusters. And then we can also have recommendations for users in terms of like what are some low-hanging fruits they can do to, improve their own productivity, improve query performance, but also drastically reduce the computational footprint and the overall cost to their company.
That's excellent. Are you using the mainstream foundation models, or are you training your own models, or a mix?
So it depends on what the user is trying to do. So what we do at Keebo is we're not replacing the data engineering team. We're basically augmenting them. We're empowering them to get more done. Like our mission at Keebo is to empower data teams to basically take control and drive growth through our vision. So the data team basically defines their own performance guardrails, their own goals. So for example, if a team's goal is to say, you know what, this is a mission critical workload, it needs to finish by this particular time, then they set up those guardrails, performance guardrails in the system. And then we basically train our models. And to answer your questions, in that situation, for example, we leverage reinforcement learning. That's,
Yeah.
roughly the third step in generative AI is reinforcement learning, right? You train an agent, and much like how you teach your kid how to, for example, eat, right? Whatever they eat without making a mess, you congratulate them, you clap for them, right? And every time that they make a mess, you tell them, hey, you shouldn't do that, right? So the same way, uh, with reinforcement learning agents, every time that agent makes a decision, for example, that agent decides to send this query to a different warehouse, or decides to reduce the size of this warehouse, or to optimize or increase the memory on a particular instance, every time it makes the right decision. And what's the right decision? It depends on what the user's goal was. If the user's goal is to save money without improving, without causing the performance slowdown, then whenever the agent takes an action that leads to that outcome, we reward the agent. And whenever it takes an action that doesn't help with that outcome, we penalize the agent. So very quickly, these agents become an expert in your own workload. And it actually allowed people to think that, hey, that's going to take days or weeks or months for that agent to learn my workload. But the thing is, we actually accelerate the learning. The models actually start warm. They already have built-in knowledge, right? General knowledge about how Snowflake works, but they also pull the metadata from the last 3 months. So most of our customers actually see significant savings in less than 24 hours from the second that they onboard. So these models are actually very, very quick to learn and start delivering value. That's the beauty of reinforcement learning. But we've also started investing in allowing users to leverage Gen AI and LLMs to actually rewrite queries. We actually have papers out there that people can read in terms of how you can build. So the work is called, the product is called Gen Rewrite, where we actually leverage generative AI to rewrite these queries using an LLM, but in a way that preserves the semantics, make sure that the rewritten query returns the exact same answer, but also is significantly faster.
Yeah, that's excellent. And on top of the hard cost savings here that you're providing, just on the utility that we described as Snowflake, and other data lakes and infrastructure. It's also there's also an element of total cost of ownership. Because when I'm a data engineer and I get tons of requests from my business team, my first response isn't, oh, how do I make sure this is cost optimal? No, I'm spending 100% of my brain power to make sure I'm solving the business problem, and then delivering that and getting acceptance and thumbs up from business leaders that these new reports or these new data applications are working and providing value. If I can just have something that will automatically cost optimize everything for me, right? I want to be lazy. I want to just write bad SQL because that's fast. Right. I can optimize anything if you give me extra time, right? But having a tool kind of do that for me, right? It just accelerates the time to value there, and overall cost of ownership of building and maintaining these data pipelines. So yeah, it's a great application of AI for that specifically. So yeah, I love your approach there.
No, thanks for saying that. So I think one way to look at this is, to your point, like it's like given enough time and patience, everything's possible, but there's a cost associated. So one of the biggest problems that we see teams face, like we were talking to with this major insurance company, their C-suite got really excited about this. So they decided we're going to use Snowflake, right? But then the adoption was really slow. So they purchased millions and millions of dollars worth of credit. But then we landed this problem where they weren't able to onboard enough, like those use cases without the worry of, hey, what if someone leaves a 3x large warehouse on over the weekend? What if someone writes a really dumb query and then we burn through the, millions of dollars very quickly because we invested $10 million. Now we have to protect that investment. So instead of sort of being focused on how to drive value from the $10 million, now the data team becomes guardians of that $10 million investment. And the way that this works is that they have to basically build a lot of in-house tooling to make sure that they have alerting in place, that, they have guardrails in place, that people don't do silly things with that cloud data warehouse. And a significant portion of these data teams is just spent and maybe, allow me to say wasted on staring at these queries, figuring out how to optimize them, looking at the bill, trying to make sure they stay within budget and all of that stuff. And that's not value add. And that's not fun work to do, right? Like, for example, if you're an insurance company, you grow your business by offering more competitive rates, right? If your engineers are constantly worrying about how to improve those the performance every single query, making sure they don't run out of budget, they don't do anything bad, like, all of that stuff. If you could automate that and have your data teams focus on growing your business instead of running and optimizing your infrastructure, I think just you can imagine how many engineering hours, how many thousands of engineering hours are going to be freed up to do actual productive work that drives your business forward.
Absolutely. And, and now we're seeing so much evolution and fast-paced adoption of AI in the data stack. So seeing AI, like, for example, you're solving a very targeted use case using AI to optimize the compute and resources of these data engineering workloads. Beyond query optimization, like where do you see the biggest opportunities for AI to improve how companies use and analyze their data?
Beyond optimization.
Yes.
So, I mean, you've seen a lot of recent probably investment in banks, right? Like how we can actually leverage LLMs for better retrieval from your own database, right? So um, that's an area where we're also actively looking into is you can go to ChatGPT, you can go to Claude and other LLMs out there and ask general information about publicly available data. But you have these extremely valuable data sources. But the value is kind of locked up, right? So we've seen about 3 decades of BI technology trying to make the data accessible. Like this idea of democratizing data and insight is not a new one. People have been pitching for the last 2 decades, but the bitter truth is that it hasn't really happened. John Smith, who's sitting in the marketing department or ops department, is not empowered to just go and open Looker and just magically ask whatever questions they have. Right? There's these legacy internal, like, search systems, like, hey, go and search Confluent to see if there's anything. But like the search is really, really bad. You cannot really get to data. It's just like what we're seeing is that we're transitioning from search, actual conversations, right? So like Google, even like, back 5 years ago, the primary way of learning about something, you would Google it and Google would do a really good job of showing you the most relevant sources, but then you'd have to go and read those sources, distill the information, decide if that's what you wanted or not, and then go and revise your keywords and rinse and repeat, right? But now you just go to ChatGPT and ask exactly what you have in mind, and they give you the answer. So what we're seeing here is that on the enterprise side and even mid-market, people are trying to sort of have the same conversational interface to their own internal data. Hey,
Mm.
curious what happened yesterday. Did we sell more in this department? Right? Or I see that basically my cost of customer acquisition has gone up today. What are the biggest root causes of like you need a really competent data science team to go and perform those root cause analyses. And it's going to take them a long time to come back with reliable answers. But if you have a rack, right, like built up internally where you can hook it up with your own database, have an LLM next to it, in a way that addresses cost considerations, right? You're not burning through thousands of dollars on LLM invocation costs, API calls, where it addresses hallucination problems, and it addresses compliance problems. You're not sharing your internal uh, confidential data with an outside LLM. It addresses security concerns that, hey, I am authorized as a user in this company to look at this particular table and I can get quick, meaningful, actionable insights. I think that's where the future lies. There's to be honest with you, there's an arms race here. There are a lot of people trying to provide solutions in this space.
Yeah, it's a super interesting area, and kind of combining the whole semantic layer with this just natural language interface where, like you said, someone who kind of just wants to ask kind of arbitrary questions about the data, right? and get very useful answers, kind of like what we're getting today. Like you can chat with Chat GPT, you don't have to be particularly specific about what you want. And obviously the more specific you are, the better responses you get. But you can still get great responses just by chatting, right? Just without being too precise. So, being able to extend that to data, where data like queries are typically very like deterministic, and you have to
Exactly.
know the exact table, you have to know the data model, you have to know the right way to query it, et cetera. Now you can kind of open it up by saying, okay, just let me chat with the data. You figure out what SQL that's going to generate,
Perfect.
or you figure out what Python you're going to write to come up with
To
that
get that
insight.
insight, exactly.
That's an exciting area. Yeah, for sure. And yeah, so hopefully we'll see some cool stuff continue to come out there.
No, for sure. I think those three like traditional considerations are still going to be there, right? Like cost is going to be there, right? The cost, the effort, and the accuracy. Those are the three things that I think are going to be the constant in all of this. That like we saw like with the adoption of Snowflake and Databricks, people very quickly realized these things can get very expensive very quickly, right?
Mm.
Um, then the effort needed, right? The amount of like we actually I've never seen a company that's spending, for example, more than $10 million on their Snowflake or even north of $1 million, except that they also have a significant a number of engineering cycles being spent on monitoring it, optimizing it, worrying about it, right? And it just makes you wonder, is it actually worth a company that's in a different industry to go and build tooling to monitor their own tooling spend, right? And that's why you see all these FinOps solutions coming up, because cost is becoming prohibitive very quickly. But then the way that people are trying to address cost is by putting in more effort, which is again expensive, right?
Yeah.
So people have figured that, hey, we're spending, for example, $5 million on our Databricks or on our Snowflake. So maybe if we have 3 full-timers just constantly optimizing these pipelines and keeping an eye on it and whatnot, that's 5 times $250,000. That's not too bad, right? But if you think about it, that's not a really good ROI, right?
Yeah.
If you could, this is exactly when you can leverage AI to monitor your own usage of AI and make sure that things, the wheels don't fall off the bus. So to say.
Yeah, and when I look at what data teams want to do, just generally with AI, when it comes to business logic and their own internal applications, you'll see data teams kind of gravitate towards, they understand that and they want to implement it. But cost optimization and, some other, kind of things that are adjacent to solving the core business problem is such a great place for AI to just solve that for you, right? And I think solutions like Keebo make that super simple, especially since you sort of in your own way generalize the problem, and you've done reinforcement learning on your models constantly, and you're bringing that in with your products. So like one thing I want to ask you is, Snowflake users are constantly, have trade-offs between performance and costs. How does Keebo help them strike the right balance between keeping queries fast and then cost optimal at the same time?
It's a really good question. I think the biggest learning we've had, I mean, we've worked with hundreds of data teams, right? Um, like literally hundreds of these data teams, if not thousands. The biggest learning we've had there is that there's no one size that fits all. The the particular data team at this particular company at this particular time has a completely different view of what's considered the right trade-off between the two than a different company. Even within the same company, we see very different understandings of what's considered good performance on this particular workload versus this other one. There's situations where the customer says, you know what, this workload, as long as it finishes before 6 a.m., so the dashboards are up to date, I couldn't care less how long it takes. Just keep the cost low, be as aggressive as possible as you want, as long as the jobs don't fail, they finish before the first employee shows up. And then there's some, other workloads where like, this is it. Like if this thing slows down, people start complaining, and then I'm going to rip off the solution. So what we have done is we followed two design principles in our product. And I think that's been incredibly helpful, both to us as well as to our customers, aligning what we're doing with what our customers are looking for. Number one is that we've decided that whenever there's a fork, we're going to go with performance. And the reason for it is when you talk about full automation, the analogy I usually give is like autonomous cars. Like an autonomous car, when you're building an autonomous car, your first crash is going to be your last crash because people will never trust you. So if I save this customer, let's say I could save this customer 30% today without any chances of a slowdown or negative impact on the pipelines, or I could push it and save them 35%. But there's a small chance that some of these queries are going to experience slowdown, and the users will complain, and then the customer will complain, and then the trust will be eroded. So whenever there's a situation like this, we actually go with a 30% savings, not the 35%. And the reason for it is no one gets angry. No one yells at you, why you only saved me 30% instead of 35%. Right? But they will yell at you if you cause their work pipeline to break. If you make the users experience, degrade, they're going to complain, right? The same way with an autonomous car. If you get home at 5, right, you're not going to complain, why did my car not get me home by 4:58? It's just 2 minutes of delay. Like, so what? It took a suboptimal route, maybe drove a little slower than it should have. It's tolerable. But if that autonomous car gets you into a crash, you're going to be really upset. So that's the first thing we followed, is that all other things even and equal, whenever we have a fork, we go with protecting performance rather than saving more money. Right? So the default is, how can we save the most amount of money without impacting performance? That's what we call no-brainer savings. Because if we tell customers we can save you, cut your Snowflake bill by, let's say 40%, but 10% of your queries are going to be considerably slower, then they have a trade-off. They have to think about it. Those decisions, believe it or not, are very difficult. They're paralyzing decisions because you don't know how people are going to react to their queries taking 10% longer. But if you told that same customer, guess what? I can save you 30% and no impact on your work. That's a no-brainer. No one has to think about it, right? So that's the first thing we've done. And the second thing is, back to what I was sharing earlier, every customer is unique, every workload, every warehouse is unique. We have the most comprehensive suite of basically flexible suite where basically people can go in there and pull their own levers. We have a slider, for example, where they can say how aggressive or conservative they want to be with this particular workload. That's the first layer. The second layer, they can go in there and actually define SLAs. That's, for example, I want to make sure the 99% latency stays less than 2 seconds. I want to make sure the number of queued queries is less than this and that. There's another layer on top of it where they can actually even define rules that the system will protect. So those are all guardrails. And then we train the agents, AI, to actually operate within those guardrails that the users have specified. So the short answer to your question is we never have to make that decision. What we have done is that we built a very flexible interface where users can tell us what is it that they consider their performance and what is their goal. And then the agent exactly delivers what they care about, whether it's productivity, improving performance, maximizing savings, etc.
Yeah, it's so interesting, and it might be one of those things where like if I ran a data team and I really had to solve, let's say the FinOps team or the finance team has been on me about my cloud costs. First I would use something like this to optimize my costs, and then see is anyone complaining by the queries being 10% slower. If yes, then I'll pull the throttle back on cost optimization. But so, but like you said, I mean, it's no one size does not fit all, for sure.
Yeah.
And it's definitely something that every data team needs to evaluate for their own operations and their own business. But it's great that you kind of figure out how to add the right levers and ways for them to approach that. And I like the autonomous driving example because it's like, yeah, I need to be home by 5 p.m. I can probably sacrifice, some time to get there safer and more comfortably, smoother ride, less lane changes. Like maybe I'll get there at 5:02 p.m. That's fine. But if it's going to get me there at, 5:45 p.m. because it's going to drive in 10 miles per hour in the right lane the whole time, then I probably won't accept that. That's
But I really like your example too. It's like, that's exactly the kind of interaction that you as a data leader were able to do, is like to try something, wait to see if people complain or notice. And if
yeah.
not, then that's okay. And then you try again until you find that sweet spot, right? So that's exactly where humans can handle that, right? And we rely on our champions and our data engineering that's leveraging Keebo to have those kind of decisions, make those kind of decisions, and have those kind of conversations. We just give them the levers that, hey, if you want to go 10% more, here's a lever. And then you tell us if it was too aggressive, you pull it back.
Yeah, exactly. Barzan, you have both a academic background and an entrepreneurial industry background. So I want to get your take on this. Where do you see AI-driven automation going in the next, 1 to 3 years?
I usually say, like, predictions are incredibly hard, but also incredibly easy. And the reason is most of the time when people make predictions about the future, no one goes back and holds them accountable
I will. No, I'm
afterwards.
kidding.
So that's why I said it's hard and easy. But joking aside, I think a lot of what we're seeing, like LLMs have really gotten to a point where there's the analogy I give people, it's not an overnight thing, right? Like if you're staring at the wall, right, and someone has a ladder stood up against that wall and they're climbing that ladder every single day, they're making progress. They're getting closer to the top, but you're waiting on the other side of that wall. You don't see any progress, right? Until that person, their head makes it above the wall line, and then that's when you see it. So to you, it feels like a sudden thing where, after, let's say, 20 minutes, nothing was happening, and suddenly you see a person's head, and now you can see more and more of their body as they climb that wall. But for the person who was on the other side, it was not an overnight thing. They've been, basically climbing that ladder continuously, right? So I think that's a different perspective between academia and industry, right? Like it wasn't like, hey, suddenly now we have Chat GPT. Like, we've been part of that progress and witnessing it and witnessing it and contributing to it, like for the past decade and a half, 2 decades, right? But I think finally the compute power and the, you know, the sheer volume of data that we could actually train these models on got us to a point where now the public can see the value. Right? So you asked me what I think is going to happen a year to 3 years from now. I think we're going to see basically a lot more real world adoption of basically these agents in all walks of life. Right now, it's just a cute thing to go and ask ChatGPT, but like people are actually building interesting verticals and apps on top of ChatGPT, where you can, for example, now go and redline your document, review your your lease with these agents. Like, you're hiring someone in a completely different country, you can actually ask one of these LLMs to check for compliance, right? Because they have trained on those the local laws and all of that stuff. So I think we're going to see more adoption over the next year. But if I were to look at the next 10-year horizon, I think what's going to happen, honestly, is that a lot, like, I don't want to say software engineering is going to go away. Like, because there are people who say, you know what, no one else is going to be writing code. Everyone turns into a prompt engineer. I don't think that's going to happen, but I think what will happen is that an average engineer will be a lot more, those engineers who want to stay relevant, whether a data engineer or software engineer, they will be a lot more well-versed in machine learning, statistics, and AI, right? I think what's happening right now with this, I guess over the next 12 months, and this is something that's been happening over I would say, for the past year and a half, and probably another year, we're seeing some irrational resistance. And you see some engineers or some teams feeling threatened by AI, that, oh, AI is here to take my job away. So what happens is that there's still a lot of teams who are very reluctant to try to build every tool inside. I mean, we face this with Snowflake too. Like, you'll be surprised how many people want to actually build their own optimization tool in-house. And this tendency to, I think...
That sounds awful, by the way. I would never volunteer for that. But
no, you shouldn't. It's a buy versus, like you said, it's a probably century-long, buy versus build kind of question. But I would say that's going to change quite a bit over the coming years.
Yeah, absolutely. And, when I hear that, being thrown around, AI is going to replace engineers, I always just look at, okay, well, why are Anthropic and OpenAI hiring all these engineers that are supposedly going to get fired in the next year?
My joke is that if you're afraid that AI is going to take your job away, it probably is. So instead, you need to learn more about how you can best leverage AI rather than resisting it and being...
Absolutely. Well, Barzan, this was really great. Thank you so much for joining us today. And thank you to all the listeners for tuning in. Barzan, where can people continue to follow along with you?
If they just go to Keebo.AI, Keebo.AI, or follow me on LinkedIn.
Excellent. We'll have those links down in the show notes for the listeners. Barzan, thank you again. And thank you to the listeners for tuning in.
It was a great pleasure, John. Thank you so much for having me.